All right, so where are we at now? Make sure I did the last one. Okay, good. How many solutions to the equation 2 sine squared is 3x minus 1? You can do this on TI-84. Putting it in is a little interesting. First off, you got to make sure you're in radian mode. That's a big deal. All right, off to y equal. The issue is putting in sine squared. You have to do 2. Well, let me put that in y1. 2 parentheses sine. Was that 3x? Close parentheses squared minus 1. And we want to know where it's 0. And our window here, as it talks about from 0 to pi, it's going to have an x min of 0 and an x max of pi. And then graph. There's 1, 2, 3. Looks like 3. They got a 6 there, though, don't they? Let's play with the window a little bit. Let's change the y min to be 0. Or actually just negative 1. I'm a little curious if it's actually crossing the x-axis. Because you'll notice 3 isn't an answer, is it? Oh, well, I see why. That's what it is, right there. A syntax error. Try this again. There we go. One little parentheses. Looks like it's going to be 6. 6 answers. All right, what is the angle between the vectors 1, negative 4, and 7, 2? Round to the nearest tenth of a degree, and as of 228, we haven't done this yet. It's actually pretty easy. You can kind of think of vectors as an ordered pair. They're actually an interpretation of slope. That's what they are. But these vectors are presumably in component form. I don't know. Anyways, you've got a vector with an x value of 1 and a y value of negative 4. And I'm so tired I drew my grid wrong. So I'm pretty shot. Sorry. I know there's a formula for this too. Question is, will you remember the formula? Anyways, where was I? Oh yeah, and I still drew my grid wrong. I've got 7, 2 in there too. Let's do this. To the right 1, down 4. Let me get my pen. Forgive me, it's early and I haven't woke up yet. And the other one's at 7, 2. That's what I did. I just connected the origin to that point. That's how you do it. 3, 4, 5, 6, 7, 2. And that's at 7, 2. And they want to know what this angle is right here. That's what they want to know. And what's the best way to do that? the easiest way to do it, if you approach it from a geometry standard kind of point of view here, is to find this little angle. Notice mine's off, and to find this little angle, and then add them together. So I think that's what I'll do. Makes sense to me to do it that way. Do I have enough information for that? I probably don't, so let me actually find this. That'll help. So what I'm going to do is I'm going to find this little angle right here. That was 4 down, 1 across. I'm going to find this angle right here. Now, notice that the angle I actually want is over here. That's the one I want, this one right here. And then I'm going to add to it that guy. We call it theta 3. Theta 3 is 72. But I need to find theta 2 and theta 3. That's the actual deal. The angle I want is going to be theta 2 plus theta 3. And I'll push some buttons to get these angles. Let's see here. Put myself back in degree mode. Maybe. This one was 1 unit across, 4, arctangent of 1 over -4. And we're just going to keep the positivity of it, 14.04 degrees. So this guy right here is going to be 90 minus. (75.96 degrees). All right, now I'm over here. The reason I'm doing this is because we haven't talked about vectors yet, and I don't want to blow your mind with a formula. Arctangent of 2/7. It's the longest way to do it. 15.95 degrees. So I'm going to put those two things together. I've got 75.96 plus 15.95. (91.91). They were hoping you guys would draw it and just pick A and feel confident. All right, 27, we have what is the solution set for the equation? 27 is a straight up TI-84 problem. This means empty set, by the way. There's nothing in it. What do we have here? We have root 4 minus x. And we have 2x plus 13. Resume 6. There's the square root. Looks like there's one answer. The only one I see. Second trace 5. You know, some of these have 2 solutions. They're hoping you'll do it algebraically and forget to check for the extraneous. One answer is at -5. Right there. The one answer. What is the exact area of a triangle with side lengths 5, 7, and 10? So it's just a triangle. They don't tell you much about it. And what you do is you get to use Hero's formula, which most of you know. It says area is the square root of s times s minus a times s minus b times s minus c, where s is a plus b plus c over 2. That's how hard this thing is. It's not a hard problem. So the semi-perimeter here is going to be 22 over 2, which is 11. And my area is going to be the square root of 11 times 11 minus, let's go with 10, times 11 minus 7, times 11 minus 5. And what am I going to have here? I'm going to have a 1, I'm going to have a 4, I'm going to have a, what, a 6? Is that right? 11 minus 5 is 6. Which apparently will simplify on down quite a bit. What we got here? We got 24 times 11, 254. 24 times 11, 240 plus 11, 251. I just need to push buttons. I have not woke up. You ever wake up and just feel kind of stupid? That's where I am today. 264. I should have just gone with whatever I said the first time. Anyways, the area is the root of 264. I'm sure that simplifies quite a bit. That should be divisible by at least 4. It is. So 2 root 66. All right, 29. The complex roots of something. Well, so that was kind of cool then. They only want the complex roots, which is your, your imaginaries. And you're holding a TI-84. You will not do Y1. This is literally legit plug in. Imaginary and real. It's all of them. All the imaginary, all the real. So I'm just going to use the storage feature. Let's see here. Let's take a -1, store it to X. Type in the polynomial. Okay, so here's what I've learned. I've learned -1 is 0. Let's check that 4. 4 store X. You guys this year haven't really gotten to use the calculator like last year. Scroll up. 4 is a 0. All right, so let's check 2. Two is not. So forget that guy. Looks like I'm down to just eliminating the imaginaries. Let's check that 2i. 2i is not. We have a -4, and I don't think that's going to be it. Common sense tells me that E is not a choice. I'm not stupid here. Yeah. By elimination on that one, and just for the heck of it, let's check I. There we go. B. All right, if sine of x is 3/4 and sine of y is 1/5, where both x and y are in quadrant 1, what is the value of the sine of x minus y? Here's what we're going to do. We're going to cheat. X is going to be the arc sine of 3/4, and they're both in quadrant 1, so I can get away with this. Let's go to mode, degree, cool, arc sine of 3/4. It's about 48.59 degrees. Y is going to have to be the arc sine of 1/5. Is about 11.54 degrees. And then we'll put those together. I don't know why I did that. That's actually not what I'm supposed to do. I'm supposed to do the sine of that guy minus that guy. Sine of, see what it says? Sine of x minus y. Minus. I got 0.6026. So for my calculator, the sine of x minus y is about 0.6026. Guess I'll push some buttons and see which one it is. And I'm going to work this one out by hand too, just because we can. Mainly because I'd like to. I have no idea why. Anyways, where are we at here? Let's look at choice B. Oh, look, I found it. Sweet. Found it. Let's see here. Let's see how we actually do that properly. Let me go back and pull up some notes that I have open for another class. Just give me a second to find them. Okay, maybe not. That's what I want. I want that little guy right there. So here's your actual formula. That's what we're doing right now. So I may as well do it the proper way. And it's legit plug in. Now you are going to have to know the cosine. So let's talk about this little triangle. Put x there. The sine ratio is 3/4. Missing leg is 5. So if I'm looking at this triangle, I know that the cosine of x is going to be 3/5. All right, here's my other triangle. So y, opposite over hypotenuse. The hypotenuse, if we do 25 minus 1, we get 24, which is 2√6. That was 5 squared minus 1 squared equals b squared. That's all that was, which is √24, which is 2√6. So I know the cosine of x is going to be 1/2√6. No, it's going to be 2√6/5. All right, that's better. All right, so let's follow this little guy here. We're doing sine of x minus y. So the sine of x is up here up top, it's 3/4. The cosine of beta, which is y, is going to be 2√6/5. And we take away the cosine of alpha, which is 3/5, times the sine of beta, which is 1/5. And we will have 6√6/20 minus 3/, something's wrong. Cosine of alpha is 3/5. Oh, God, I'm an idiot. I'm a huge idiot. Look at what I did, man. I did something that a 10th grader would do. Oh, I need to go to bed. This is √7. So cosine is √7/4. Oh, this is better. 6√6 minus, I wonder why I got that 3 there. 3 is a carryover from above. I should just go home. Minus root 7. Both pieces are over 1. Bad math teacher. Math teacher needs to wake up. For sure. All right. Triangle has side lengths 7, 10, and 12. What is the measure of the smallest angle to the nearest degree? And they don't tell us what kind of triangle it is. This should be the smallest angle. It should be. And that should still be true, but the smallest angle is opposite of the smallest side. That's just how it works. Now, what does she measure? Probably not C, probably not D, probably not E, probably B. Anyways, we'll do law of cosines. C squared is A squared plus B squared minus 2AB cosines of angle C. And this is my angle C, but I don't want it because I'm pretty sure that's it. So little c is 7, and A and B are 10 and 12 respectively. And what I don't know is I don't know the cosine of C. So I'm going to take these guys away. It gives me negative 195. Here I'm going to have negative 240 cosines of C. I'm going to do the division step. So negative 195 over negative 240 is the cosine of C. And then I'm going to push some buttons. Arc cosine of negative, I'm not even changing the signs, I'm so lazy this morning, divided by negative 240 is about 35.65 degrees. Choice B. All right. Company manufactures metal cans, designing a cylindrical can that has a height of 6 inches and a diameter of 3. If the top cost 0.13 per square inch, the sides cost 0.07 per square inch, and the bottom cost 0.22 per square inch, how much would the material for one can cost round to the nearest cent? So let's see here. Diameter is 3, so your radius is 3/2. Let's talk about the top. It's a circle, it's a can, right? The top is going to be pi times 1.5 squared, pi r squared. And everything's in inches, cool. So we have m times the cost. I'm just going to put the cost here, times 0.13. The top costs 0.9189 dollars. All right, now we do the bottom. The bottom is going to be the same math, but with a 0.22. The bottom is going to be 1.5551 dollars. Now the sides. This would be something that a lot of kids will struggle with because their geometry is just not what it needs to be. It used to be a state standard that you would have kids draw nets. And this length of the rectangle is the circumference of the circle. This is 2 pi r. The height is given in the text as 6. And area is, of course, length times width. We have a radius of 1.5. And the sides are going to be 7 cents a piece. I'm probably missing another set of parentheses there, but whatever. So the sides of the can are going to cost me $3.95, whatever. Let's add in what I have, plus 1.551 plus 0.9189. So pretty expensive little can to make, $6.43. Choice A. Pre-calculus class consists of 8 juniors and 10 seniors. If 4 students from the class are randomly selected to compete in the TMTA mathematics contest, what is the probability that 2 juniors and 2 seniors are chosen? I don't know if you remember this or not from my Excel last year, but this is going to be a combination. We're going to pick 2 of 8, so we have an 8 choose 2, and we're going to multiply that by the seniors, which is also going to be 2, 10 choose 2. Probably another way around this problem, but that's probably the quickest way to do it. So 8 math, let's see, that's under probability. Choose 2 is that. And we have 10 choose 2, math, probability, choose 2, and let's multiply them together, 1260. So there's 1260 choices. Wait, I want probability, don't I? Combinations may not have been the best way to do this. That gives me the total number of ways. This is the number of ways I could pick. The real question is, what's the denominator? Is the denominator going to be 18, choose 4? Combinations have always bothered me a little bit, probably because I don't have any formal instruction in them. 3060. Yeah, I don't like. Let's see what 1260 over 3060 is. If not, I'm just going to go the classical way of doing this, is just to make choices. 1260 out of 3060. 7/17. Maybe. All right, here's what I would probably do on this one then. Thought it might be a combinations problem, and it probably is. So let's talk about picking kids. The first choice I get to make is I can pick 1 of 8 juniors, and the next choice I get to make is 1 of 7 juniors, because I've pulled 1 from the pool. All right, that handles the juniors. I have the keyword and, so I'm going to be doing some more multiplication. Talk about the seniors. I can pick 1 of 10 seniors. And then I can pick 1 of 9. I don't like the way that looks either, do I? I'm having a brain fart on that one. Let's pause this. Give me a second to recollect myself. So yeah, I decided to just go back with combinations, and the key checks out. It's choice B. So just what I did earlier. Well, I don't know what's up, man. Yesterday I was just nailing this stuff, and today